All right, so we're going to learn how to interpret something called an atomic symbol. These are found on the periodic table for every single element in existence. So, looking at this box, you've got 4 pieces of information that we can pull out, and then we can use a nifty acronym called APEMAN to get even more info from those 4 basic pieces. So, first of all, whenever you read an atomic symbol, you want to start by reading the element name. This one is carbon. Then you're going to look at the element symbol. Element symbols are 1 or 2 letter abbreviations or shortenings of this full name that makes it easier for us to communicate and write about that element. So for carbon, it's C. Then this is a super, super important piece of info. We have something called the atomic number. For carbon, it's 6. This is kind of like an ID number for that element. No matter what else is going on, if the atomic number is 6, that is a carbon atom. You will always know that. All right, and then the last piece of info down here at the bottom is something called the atomic mass. This does give us information about the total mass of that element, so protons plus neutrons. There is some more detailed info that we'll learn about atomic mass a little bit later. That's kind of special and helps explain why this isn't a whole number. But for right now, just know that atomic mass is going to be protons plus neutrons, and we'll expand that definition later. Remember to put units whenever you write the atomic mass, because we don't do naked numbers. It's not that kind of party. So for this carbon atomic symbol, the atomic mass is 12.01 AMU. All right, now let's use APEMAN to get some of this info that we want to know about this element. Sorry, y'all. First of all, number of protons. If we look at the first part, APE, atomic number equals protons or electrons. So protons are going to be equal to the atomic number 6. I'm actually going to switch over to text because it's a lot easier to fill in the table that way than trying to write. So we got 6 protons. Neutrons. That's going to be equal to something called the mass number. The mass number is equal to the atomic number plus the number of neutrons. Now you might be saying we haven't really talked about the mass number yet. For right now, just consider the mass number a rounded version of the atomic mass. So if you see 12.01 on the atomic mass, you can think of the mass number as being 12, because that's the closest whole number. We're going to talk again more about the difference between a mass number and the atomic mass later, but for right now, we don't need to get into all that. So 12 is going to be equal to the atomic number 6 plus the number of neutrons. Ooh. And again, I was getting ambitious there trying to use my pen. That's not very good. 12 equals 6 plus n. So if we take 6 away from both sides, then we will get that 6 is equal to n. So we have 6 neutrons. Then electrons. We can make the assumption that this is a neutral atom. So electrons are going to equal the protons or equal the atomic number, however you want to think about that. So we will also have 6 electrons. Now, the mass we already pulled out as being 12. So we can write 12 AMU. Even though the atomic mass has a decimal on it, when it just asks us for a mass or a mass number, we really want a whole number. And finally, charge. So like we said, when we look at an atomic symbol, we generally assume that we're talking about a neutral atom. So one where the charge equals 0. That's how we know that the protons and the electrons have the same number. We will look later on at examples of things called ions, which either have a positive or a negative charge. And now you know how to interpret an atomic symbol.